Hello, welcome to the latest episode of Data Unchained. I'm your host, Molly Presley. So you can see we're at a convention today. We're in Atlanta, Georgia at the SC24, so Supercomputing 24 convention, where the thought leaders, technologists focused on high-performance computing, supercomputing, and AI infrastructure are here sharing the latest and greatest and the tools that are available to them. So if you're new to Data Unchained podcast, let me give you a little bit of a summary about what this show is about. We focus on how data has become an increasingly decentralized resource. It's being created in sensors in the sky, off of rockets, off of your vehicles, in massive data centers and in the cloud, and harnessing that data, knowing what you have, and then being able to put it to use to drive new products and services is a challenge that everyone here at this convention is focused on solving. Today's guest is David Cerf. Welcome, David.
Thank you, Molly. Great to be here.
David and I have known each other, I want to say,
for
a long time.
Yeah,
I won't say. So it's great to have you here on the show. Maybe just tell us a little bit about your background kind of in technology or some of the extreme sports you like to do or anywhere in between.
Wow, I've got to think back. So it started in database and accelerating data from there, and then moved into big data archives and learning tape with you, actually. With
Active Archive?
Active Archives, and just looking at workflow changes, being involved with companies that were very focused on the use of data, of course, storing data, and now with GRAU data, we're very focused on the user space and this change that's coming from AI and driving the need for more data all the time. And so I've been involved with software that has always worked somehow in improving how the user can access it or understand it.
Okay, cool. So GRAU Data, maybe tell us a little bit about that company.
Sure. Well, who doesn't know GRAU data? I mean, Herbert Grau, who is the namesake and founder, goes back to the history in tape libraries.
Quite a luminary in the industry, for sure.
It is. If you can spell
Herbert.
tape, most people know who Herbert is. And built some of the first libraries back when it was just him and IBM. That technology and knowledge came forward in the current version of GRAU Data, which is a 20-year-old software company. And we have several different products that all focus everything from archive, data protection, and metadata mining, and all wrapped around the same type of things, being better access and management of data.
So I would imagine the evolution of the technologies has kind of tracked with the history of trying to figure out how we're going to store all this growing unstructured data to how you put it to use. Is that a fair statement? Okay.
Absolutely. And it was interesting. I kid with Herbert, the first time I ever heard the word archive and library, I was in his office 20 years ago. And I was like, why are we talking about libraries? What do books have to do with this? True story. It was funny. So I got a lesson on what all that meant from a hands-on, build it early on before people even really thought about the workflow that we have today.
Okay.
But just keep everything.
So you keep everything. Unfortunately, capacity on all the devices, whether it's SSDs or memory or disks or tapes, has grown. So having a place to put it is not such a big problem anymore. But knowing what you have is something not many organizations have really been able to figure out yet. So let's talk about metadata. You have a product called Metadata Hub. What does it do?
The best way to think about it is what you mentioned is we have a big data problem. That's one part of it. The second part is I have all this data. How do I understand what that data is? And the analogy I like to use is a jigsaw puzzle. So if you imagine that we have a jigsaw puzzle, but we have no idea what the picture is.
Okay.
So no idea what we're trying to build, and then we have no idea how many pieces we have. So we never know if we're done. And that's how unstructured data can look to a lot of users. Is we have this massive volume. We may know that there's a file somewhere, but we really don't understand what's in it. And the change that's driving this is that most of the volume of data today is generated by machines. So as you mentioned, satellites and sensors and microscopes, and they're producing volume at a rate that is just difficult to store it, but deep within that file is the information that we really need to discover and use this information. And so the ability to get to that insight comes from metadata. There's two parts of the content, the two parts of the file. One is the content. So if we have an image, The image is pretty straightforward. It's a picture of something maybe as an example, and the items in there, right? It might be a picture of me and my dog, and so that's pretty clear. But what tells me more about that is the contextual information that may be generated by the machine itself. So if it's a camera, that could be a GPS location or the contrast, and so that's pretty straightforward. But when we get into scientific research and advanced anything using data intense type tools, the volume of that metadata becomes critical to understanding it. So like in a microscope, there might be tens of thousands to hundreds of thousands of metadata tags that provide the relevance and the contextual information to understand what that file is and why it's relevant to the data user themselves and the discovery. And that's all metadata.
And this is important when it's shared data. Maybe the person who generated it, let's use the microscope example, maybe a researcher knew a lot about that data, but somebody else is trying to use it and they don't know anything. What is the instrument, the date, the patient, whatever. So that becomes really important when you're talking about sharing these data sets for larger projects where there's a many-to-one relationship of the users to the data instead of one-to-one, right?
Well, you're absolutely right. That is a problem, but I think the users are overwhelmed because they've never had access to this. A lot of the data that they're now able to access and this deeper metadata was difficult or impossible to extract. And so they may have built a hand extractor of something, but again, to manage the volume, we're not talking one file type, we're talking many file types. So multiple microscopes, or in genomics, you have multiple different ways to pull data from different file types and sequencing. And so there's a challenge on just even understanding the hundreds of thousands of metadata tags. The user may not even understand it.
Right.
So one of the things that Metadata Hub does is not just capture the content and context to where they can provide that back to the user and their applications, but we actually integrated AI that actually assists the user and provides that ability for them to understand that. So they can actually interface back with Metadata Hub and say, well, what is that? I've never seen these tags before, or what are relevant? And they can actually interface through a chat interface, or of course we could feed that up into LLMs as well, and you can interface. However the user wants to utilize that data and the workflows that they already have, we enable those, right?
Okay, so let's unpack that a little bit. So the user experience, they are creating data, and the metadata is being created by the instrument or by Metadata Hub? Where's the who's assigning all these tags? It's not a bunch of people typing the metadata,
no, that's a great question, actually. And the clarity, because I think we misuse the word metadata like we used to use the word cloud. It meant everything to everyone, and metadata, particularly in storage, can become confusing. A lot of people immediately assume we're just talking about POSIX metadata, that file system metadata.
Right.
And we capture that. Of course, that's relevant, and so is the object metadata. And of course, the user metadata. So users are generating their own sets of tags, and we capture that. But the volume where we specialize is in this high volume machine generated. So the volume of these files that are coming out every single day, and we're talking not just millions, but billions of files. And we have customers that generate billions of files every day even, right? That's just too much data for any individual user.
Okay.
So we're getting all of that metadata and we bring it into an automated workflow where they can define how they want to consume it.
Okay.
Whether they're using an application or they could query. There are researchers that are very specific in the data sets that they want to look at, and they're trying to isolate it. But the other way to think of it is populating a data lake and being able to better utilize that versus trying to manage, just bring volumes of files back. By being able to capture that information in the contextual and content value, you can actually work from that versus having to pull the actual physical file to always get into the data itself.
Okay, so an application can work with this metadata. You could trigger, like with what Hammerspace does, data orchestration jobs of, okay, I know what data I want, now move it next to this compute or whatever it is. So that's cool from a machine side. Users can query it themselves if they want, if they're a data engineer or a data scientist or a researcher, to find their own subsets of data. When you think, though, about how this runs, is this an in-band kind of thing? Like, how does it get installed? I have data sets in storage infrastructure in the cloud and the data center. Where does Metadata Hub run?
Yeah, so that's actually really one of the things we're helping solve, is that getting the data out is half the problem. And so we reside local to the physical storage, in proximity to where, if they have it in the cloud or in Amazon or in the edge, wherever the physical storage may be in the filers or in the object stores, you would have an instance of Metadata Hub running local. And one is, you don't want to bring data part of our value is we don't have to move data unnecessarily. As a matter of fact, we would give a list back to Hammerspace, and Hammerspace would do the movement. So we don't do any movement, we don't do any of the analytic element on it. And we read only the data back. So we're going into the file, extracting that embedded metadata, and maintain that locally. So we create a data mesh architecture, so it maintains in this distributed approach, but then have a global layer or for global search or to provision data from all those instances back as a single accessible store.
Okay, and then this is updated real time as new data is created. Can you go back and look at old data too and create this information?
So anything that's in a file system or an object store, we can go back. You wouldn't normally do it as it's created, kind of like it's created and at that point daily it's collected, so it's not instantaneous, but it is quick.
Okay.
Right, and then absolutely you can go back and scale, depends on how much data you have.
And instantaneous doesn't really matter in this situation because you're not in the line of the GPUs making the data. This is a long-term strategy of knowing the data, using it, and understanding it. So that doesn't have to be major high performance like if you were in the data path per se.
Right, but if you're sitting with some number of files, millions and billions of files, you'll set a schedule, and depending on the value of the data, you can start harvesting. And then as net new data is created every day, that data is then captured as well. And at some point, you've collected from the deployment, you've collected everything, and then it's just the net new data.
Okay, and tell us, Kev, as we wrap up, what kind of environments use Metadata Hub? Is this really a AI GPU computing thing, or does it go much more broad into other types of enterprise use cases?
It's really not a general document management. It's not for our PowerPoints. It's for data-intensive users and anywhere there's a data scientist.
Okay.
So you have these complex data sets that are being driven. Life sciences is really probably the poster child these days, but weather data, manufacturing, architectural design, anything in geospatial, weather, those type of things where you have these complex file types. Complex,
unstructured data that you're trying to put to use, and maybe you're going to compute on it, maybe a researcher's going to use it.
Right, and I think the AI is changing the demand. It's the desire to have everything, but I don't know when I need it. And so by having the metadata in this proxy, everything is instantly available for the majority of what they want to do. At the point they would isolate a data set, that list can then be, as I mentioned, handed to Hammerspace, who can ensure that the physical files are back to where they need it, and there's that intelligence. So Hammerspace, being metadata aware, can now leverage this deeper granularity that it comes within the file to create content awareness.
Okay.
And that is a whole new level, because if we're thinking about where GPUs, I think the challenge for a lot of users is that in itself is an expense, and Hammerspace brings a lot of value on improving that load. Well, we improve the fact that they can isolate instead of having to bring unnecessary files, because a lot of the workflows are to just bring that group of data back. Well, why not isolate what I need before I bring that back and get to the exact set and be more specific? And that's that type of focus that we can help enable. So that's very impactful when we think of AI architectures and the impact on resources to enable better performance around the GPU and the network, even the storage.
Makes sense. So the technology you build at GRAU doesn't stop just at the metadata side, but there is definitely a storage and workflow component about it. Maybe talk a little bit about object storage and some of the technologies you have for those object-based workflows.
So GRAU has Extreme Store, which is a S3 to tape solution software. And it's very straightforward. It presents a Glacier on-premise. So if you're already writing to Amazon Glacier, you can literally repoint to the Extreme Store and you would have the same user experience. So the Extreme Store software provides that ability to present the object store, and then below it, underneath it, it's managing the disk cache, both a read and write cache, and that can be as large as the customer wants, so we don't actually charge for that. And then any tape library, so you can have a vendor-neutral architecture. What's important is our customers for that product are very large. It's all about scale, right? The way we're seeing tape have a resurgence today is pretty exciting.
So it's a really cost-effective, well-protected storage tier on tape, and then integrated into your S3 workflows, which are very common. And then on top of that, Metadata Hub can run to describe and understand what data is within that environment.
So actually, when you combine the Metadata Hub and tape, it really becomes the killer app. Metadata Hub, because it can extract all the content and context, provides users most of what they need. They may never need to touch that file again. So what better place to put the file than on tape? If I really want to keep it and have it accessible when I need it, and Hammerspace ensures that that data is always accessible, might as well put it on the most cost-effective tier.
Right.
So Metadata Hub in the front, capturing it as that file is created before it goes to tape, becomes a real benefit, because I can now query and maybe never have to make that file recall out of the tape. That's a real benefit to the tape user, or to people that are just thinking object store. I think Extreme Store, what we're seeing is people think of object storage now. They don't necessarily care the medium anymore, because those workflows have gotten so smooth that they were used to Glacier. Okay, it's in Glacier. Do I want it in the cloud with Amazon, or do I want it on premise?
Okay, that makes sense. So the flexibility to have the performance tier and then the cost tier you want, and do it in the data center or in the cloud. That's great. That's really great.
And Hammerspace ensures that it all is where it needs to be
when it needs to be there. Exactly.
Yeah, absolutely. So that's the relationship. Obviously, is we're providing that ability to capture intelligence, empower those users to better use the tools from their workflow and their discovery, as well as that ability to retain it.
So if customers want to learn more, is it GRAUData.com? Where do you point them to learn more and get in contact with you all?
It is GRAUData.com, but there's also a website dedicated to Metadata Hub, and that's moremetadata.com.
Okay.
And so
moremetadata.com.
Moremetadata.com.
Awesome, love it. David, thank you so much for joining the show. I hope you have a great supercomputing conference as well.
Thanks so much, Molly. Great to be here.
Thanks for listening to Data Unchained, powered by Hammerspace. To learn more, visit hammerspace.com. If you have a guest you would like to hear on the show, email me at molly@hammerspace.com.